Welcome, everyone. My name is Ricardo Camacho, Director of Software Safety and Security Compliance at Parasoft. And thank you for joining us today for this webinar where we unveil Parasoft C, C++ Test CT for continuous testing and compliance excellence. And I'm accompanied by Miroslav Zielinski, Director of Product Management for our C and C++ testing solutions, and a great friend. Why don't you say hi, Mirek?
Hello, everybody.
Now, on the agenda, I'm going to start by providing you with an introduction of C, C++ Test CT, what it is, and why we have developed this fantastic product. I'm also going to do a quick comparison between our new C, C++ Test CT product and our crown jewel, C, C++ Test. Merrick will then give us a demo so we can see C++ Test CT in action, and then we will open it up for Q&A. Okay, before we get started, let's go through some housekeeping. First, everybody's microphone has been muted. However, if you have questions, please enter them into the questions dialog box. You can do this at any time. Also, this presentation is being recorded and will be made available shortly after the webinar. We are very proud and excited to introduce C, C++ Test CT. It's a new product to our comprehensive set of software testing solutions. Yet it's important to understand that C, C++ Test CT is an evolution to C, C++ Test, our flagship product in the verification validation of embedded C and C++ safety and security critical systems, which you may be very well using today in your organization. Now, this evolution is inspired by modern continuous integration workflows where you can integrate quality gates for continuous testing, hence the post-nominal letters or suffix CT. Okay, so let's get started into the aspects of what C++ Test CT is. In a nutshell, C, C++ Test CT is a new product for dynamic testing of C and C++. This means testing through execution, such as unit, integration, and system testing. However, most importantly, C, C++ Test CT is for teams using open source frameworks like GoogleTest, BoostTest, CPP Unit, and other frameworks for dynamic analysis in their development workflows. In addition, they also need to satisfy functional safety and security compliance requirements through test verification methods like dynamic analysis, code coverage, and requirements traceability. So C, C++ Test CT continues its heritage from C, C++ Test in support of embedded real-time safety and security critical applications, applications that require compliance to industry functional safety and security standards like ISO 26262 for automotive, DO 178CA for aerospace, IC 62304 for medical, and many other process standards. Now, C, C++ Test CT is 100% IDE independent. It is strictly a command line oriented toolchain, so it's designed for automation at scale for use in a continuous integration workflow, offering seamless integration with build systems like CMake, Bazel, and others. However, it can also be integrated into the developer's desktop. So it's an excellent VS Code extension, which you will see in action in the demo. Also, not only is it container friendly, but can be used for on-target hardware testing, which is a common requirement for testing of safety critical systems. And we know that the use of these tools for these types of application require TÜV certification, which we are in the process of obtaining and expecting completion of TÜV SÜD certification in a couple of months for C, C++ Test CT. Okay, there is much more to C, C++ Test CT, like enabling code coverage, requirements traceability, and report generation. But before I dive into those technical details and capabilities, let me put things in perspective as to why we are bringing this solution to our customers and the value it adds to the software industry. Parasoft is a very innovative company, always at the forefront of change. And we listen to our customers and analyze what trends are happening in the software industry. So we noticed that many embedded development organizations have been and continue to adopt a continuous integration type of development workflow. They mentioned that they have been able to better predict the delivery of software, that they have been able to better accommodate changes in requirements and design. But one of their biggest tells is a drop in QA problem reports and customer tickets. This has also equated to lower cost in testing and development, and they have noticed an increase in product quality and time to market. Because of these realizations, they are focused now on automation at scale and being able to deploy CI/CD pipelines for large, complex projects. The automotive and aerospace industry are primary examples of this. They are looking to further optimize the pipeline with light command line tools. We see a lot of use of tools and solutions like VS Code, Git, GitHub, Azure DevOps, Jenkins, Jira X-Ray for requirements traceability, and many other tools. In fact, many organizations are utilizing open source tools and frameworks like GoogleTest for testing and even homegrown frameworks. And I'll cover more on this topic in the next slide. But one of the key takeaways that I want you to walk away with is that Parasoft has enabled organizations and our customers to seamlessly integrate C++ test CT for code coverage, requirements traceability, and report generation into any CI development ecosystem out there, eliminating having to introduce an IDE centric, difficult to integrate and automate solution. So let me expand on C++ test CT support of open source tools and frameworks. Many embedded development teams love using testing frameworks like GoogleTest, CPP-U-Test, BoostTest, and CPP-Unit. We want you to continue to take advantage of these testing solutions for unit, integration, and system testing, but we want you to get more value from this effort by enriching them. For example, you can take a testing framework like Google Test and enhance it with C++ Test CT, which adds structural code coverage, requirements traceability, and report generation. These additional capabilities simplify and expedite compliance to industry functional safety and security regulations and standards. It saves in time to test, time to market, labor costs. You will experience a high reduction in issues and produce high quality code and products. You don't need to rewrite existing Google test cases. Developers don't need to learn a new testing framework, and you don't need to reinvent your pipeline. So this solution also does not lock you into a specific vendor, which can be actually a costly investment. Just plug in or integrate C++ Test CT into your CI pipeline, and the value becomes exponential. Now, I want to visually highlight some of the C++Test CT capabilities. For example, the ability to enable multiple report generation targets, such as Parasoft DTP or GitHub pages, where the team can easily access published reports. A report like the screenshot in the middle. Now, Parasoft DTP is a comprehensive reporting and analytics solution. It provides insights into progress monitoring for various coverage metrics and goals towards compliance with its actionable charts and trends, and assesses risk areas and helps users manage priorities. It can be used as a central reporting system. With DTP, teams can jumpstart their coverage efforts by focusing on coverage for newly added code first. Expanding on the Google Test integration, it includes requirements traceability reporting. This feature allows linking tests with software requirements residing in requirements management solutions such as JAMA, Codebeamer, Polari, and others, providing that traceability report. The traceability, along with code coverage reports, help teams understand the completeness of testing and also helps satisfy requirements traceability mandated by functional safety and security standards. Now, Merrick is going to show you some of this and much more. I have one more slide to show you before we get to the exciting demo. Again, C++ Test is our flagship product for embedded safety and security critical applications in C and C++. It's not going anywhere. In fact, a big capability differentiator between C++ Test and C++ Test CT is that C++ Test CT does not include static analysis. Also, C++ Test offers its own proprietary unit testing framework with code coverage and requirements traceability. As we just covered on the previous slide, C++ Test CT enhances open and existing unit testing frameworks like GoogleTest with code coverage and requirements traceability. Both C++ Test and C++ Test CT provide report generation and integrate with Parasoft DTP. The use model or deployment model may overlap, but again, C++ Test CT is specifically engineered with a command line interface to seamlessly integrate into your CI pipeline and into Visual Studio Code. So there's no IDE dependencies. This is different than C++ Test. C++ Test is dependent on IDEs like Eclipse, Visual Studio, and Visual Studio Code, but only for static analysis. And because it has these IDE dependencies, it can be challenging to integrate into complex build. This is not the case for C++ Test CT. It is purposely developed to seamlessly integrate and scale into large complex projects and build systems like ZMake and Bazel. Okay, let's get to the fun part. Merrick, I'm gonna pass it over to you. Break a leg.
Thank you, Ricardo. In this demonstration, we'll present how Parasoft C++ Test CT helps improve code quality and streamlines compliance with functional safety and process standards. We'll show how to provide evidence for achieving code coverage goals from GoogleTest-based unit testing and how to use Google test cases for requirements testing. Let's see it in practice. Our demo project is based on a popular open source library for inter-process communication. In our design, we plan to use it in the autonomous driving system. Our project is hosted in GitHub, and team uses a modern CI-based development workflow with containerized toolchain and automated CI quality gates. For our code, we need ISO 26262 ASIL-D compliance. So far, in the early stage, project was developed with limited attention to standards compliance. Developers used GoogleTest to add unit test cases, but the process was not systematic, code coverage was not monitored, and testing was not traced to requirements. For our next compliance milestone, we have two goals. We want to start monitoring statement and MCDC code coverage metrics for the newly created code, and we want to start tracing relevant tests to requirements. With Parasoft C++ Test CT, integrating code coverage into project builds is easy. There are dedicated integration packages for build systems such as ZMake or Bazel. The tool is also very easy for containerization. To integrate the tool for our demo project, we need a small insertion in the CMake list file and a corresponding configuration file. With this change, our build targets are now extended with code coverage monitoring, and we can move on to implementing new features. Let's say our task is implementing the emplace method for a vector class. We do have a set of low-level requirements for this new code. As a developer, I've analyzed the specification and implemented the first version of the emplace method. I've also added a first couple of unit test cases. Please note that my test cases are correlated with requirements via dedicated properties injected into test cases. This correlation establishes a test2 requirement link that enables C++ Test CT to generate requirements traceability reports mandated by all safety standards. Now I'm interested in whether my tests pass and the code coverage level for my newly implemented code. Let me build the project, run new tests, and generate code coverage reports. As you can see, the code was built and tests were executed. As a part of the build process, C++ Test CT generated code coverage reports. C++ Test CT generates reports in multiple formats, including raw text, machine processing friendly JSON, and HTML. For developers, the VS Code extension is probably the most convenient way to analyze the results. Let's enable line coverage and look at the new code we added. As we can see, we do have some code coverage, but our basic tests examined only a part of the implementation. We need to add more test cases. We can derive additional test cases by requirements analysis. Let's add a few more tests, ensuring they are linked to appropriate requirements. And execute them. We expect coverage for the emplace method to increase now. And indeed, it seems we now have 100% line code coverage. We are now ready to push the code to the repository. And create a pull request. My pull request triggered the automated pipeline. The pipeline goes through several stages, including code coverage quality gate. Let's take a look at our pipeline definition while it executes. Here, the code coverage tool is enabled for the build. No other actions are required for the integration. Our default target includes building GoogleTests. Here we execute binaries with unit tests, and here we invoke report generation targets added by C++ Test CT CMake extension. Once the report is generated, it's published to the GitHub pages so that the team can easily access it. Below are code coverage quality gates for statement and MCDC coverage metrics. Our current requirements for the quality gates are 100% statement and 90% MCDC code coverage for the new code. Let's go back to our pull request and see the pipeline result. It failed. It seems we have a problem with MCDC coverage. Our line coverage quality gate passed, but the MCDC coverage quality gate has failed. We simply did not achieve expected 90% of MCDC coverage for the new code. To understand the gaps, we can review the HTML report published on GitHub pages, or what may be more convenient for developers, we can view results using VS Code extension. C++ Test CT VS Code extension integrates with GitHub and automatically downloads the most recent results for the working branch. We can now analyze why our MCDC coverage quality gate failed. Let's see MCDC results for the method we are implementing. We have 3 decisions in the method. For 2 of them, we have achieved 100% MCDC code coverage. However, we still don't have the complete coverage for the first decision. Let's take a closer look. C++ Test CT provides extended MCDC coverage reporting that helps understand coverage gaps. In our situation, we have 3 conditions in the decision. The second and third conditions are already covered according to MCDC coverage requirements. We still don't have the coverage for the first condition. Here we have a list of test vectors that were executed as a part of our testing process. It includes information about the values that conditions were evaluated to and the outcome of entire decision. Below, we have information about missing test vectors. A great value is that the tool computes the minimal set of test vectors required for the complete coverage, helping developers to be more productive. In our case, we need a test vector to evaluate the first condition as true. It means we need a test case that tries to emplace an object at the position exceeding current capacity. Let's add this test case. In general, depending on the situation, different actions may be required to eliminate the coverage gaps, including changes in implementation, modification of requirements, and addition of missing tests. In our case, the code was correctly implemented following requirements, but the developer forgot to add a test case for a specific scenario. The problem was detected thanks to C++ Test CT based quality gate. Let's make sure our new test case is correlated with appropriate requirement, and now we are ready to push the code again. This operation triggered a pipeline for our pull request. Let's give it a minute to finish. Alright, it seems our coverage quality gates passed, and we are now ready to merge the code into master. For the master branch, we have a dedicated pipeline verifying integrated code. This pipeline executes extensive set of tests and monitors the code coverage for the entire project. Our merge operation triggered this pipeline. The results of this pipeline represent the current status of our stable branch. Our master pipeline sends the results to Parasoft DTP, the reporting platform. Parasoft DTP aggregates results from different types of testing and presents results in graphs, trends, and compliance reports. With these widgets, I can monitor my progress in various compliance aspects, including the progress with the code coverage. I can also check the progress with requirements implementation and testing. With this widget, I get information about the number of requirements already covered with test cases and those that are not, and require attention. This information allows me to react if my progress with compliance goals, including code coverage, is too slow. This kind of insight is essential for any persona involved in the safety, security, or quality process management. And this is the end of our demonstration. Let's recap. In our demo, we presented a CI-based workflow where C++ Test CT was used to satisfy coverage and requirements traceability reporting objectives stemming from the safety standard. In our demonstration, the development toolchain including C++ Test CT was containerized and used for CI pipelines and at the developer's desktop. We have gone through the following sequence. Developers started working on a new code in the feature branch. Here, C++ Test CT was used on the developer's desktop. Then the pull request was created where C++ Test CT was used as a coverage quality gate. On the first attempt, code was rejected and the developer downloaded pipeline results to the local IDE for a remediation. After applying fixes, code was successfully merged. For merged code in the master branch, another pipeline was executed. The master pipeline results were sent to Parasoft DTP for trends and compliance status analysis. Ricardo, passing to you.
Almost forgot to unmute myself. That was a fantastic demonstration of our new product, C++ Test CT in action. Thank you, Mirek. Anyways, the barcode that you see will take you to our C++ Test product page on our website. There you can learn more about this new product. You can download the data sheet, take a tour of C++ Test CT. You can request a trial or demo, and there's even an introduction video that you can watch. Also, if you have any questions after this presentation, you can email us at info@parasoft.com. We are also on LinkedIn, Twitter, Facebook, and YouTube. So follow us or watch our extensive collection of videos that we have on our website. Okay, so we have actually a few questions. So I'm going to go ahead and open it up for Q&A. Merrick, we have a first question here. Are MCDC hints and extended reports available in HTML format or only in the VS Code?
All the reporting features like presented in the VS Code, including extended reporting for MCDC, are also available in the HTML report. In our demo, we just briefly showed the HTML report published to GitHub pages, and maybe it was not obvious from the demo, but in HTML reports, you get all the information about conditions and decisions for executed test cases. And also you get the information about minimal set of missing test vectors, exactly the same as it was presented in the VS Code.
Okay, thank you. Next question. In your demonstration, you presented 100% line code coverage in the VS Code editor, but in your dashboard, you had only 70%. How is this possible?
Okay, I'm not sure if I understand the question. Let me see. Okay, I think I know what the question is about. In our demonstration, when we presented VS Code extension, our focus was on one selected method. We were adding Google test cases for this method, and in the VS Code, we were looking only at this specific snippet of code. That's why at some point, all the lines were presented as green because we completed working on test cases for this specific function. However, when presenting this dashboard and widgets, we presented the results for the whole pipeline. Tests were executed for entire project, and the widget in our dashboard displayed results for the whole project, basically. And it so happens that for this project, we don't have yet 100% code coverage, so this 70-something% was shown.
Yep, very good. The next question actually seems pretty good. In our project, we use our homegrown framework for integration and system level testing. The framework is based on Python scripts, but the tested code is in C++14. Can we use this product with our framework?
The short answer is yes, and that's a frequent question we get when we present our new product. In our demo, we were presenting GoogleTest integration because we have a special focus on GoogleTest, and we plan more dedicated features for GoogleTest framework. However, the tool is designed to be framework agnostic, and it can integrate with almost any unit integration or system level testing frameworks, including popular open source frameworks and also homegrown testing frameworks.
Okay. Our next question is, VS Code reporting looks excellent. How complicated is it to set up to use VS Code extension?
Actually, this is not complicated at all. As Ricardo explained in the first part of our presentation, the tool is 100% IDE independent. You integrate it with your build system and it produces results upon the test execution. And these results are stored in the kind of product directory, which you use then for generating various reports. And the location of this product directory is the only thing that VS Code extension needs to know about in order to show code coverage in the code editors. So there are no additional setup steps, just specifying a single path.
Okay. Our next question, my project includes different subcomponents for different ASO levels. Can I define a quality gate with different expectations for source code in different directories?
Yes, this is possible, and there is no need to parse reports in order to extract coverage results for certain resource. The tool comes with a very convenient query function, which you can use to say extract numerical result for the for coverage metric of interest and the resource of interest, like directory, file, or even certain method. So this is something that highly simplifies creation of coverage-based quality gates, even in the situations when our project contains several modules at different safety levels.
Next question is, our projects build with Bazel, and we have several hundreds of GoogleTest cases. Can C++ Test CT integrate with Bazel build and provide code coverage for GoogleTest?
Yes, that's possible. Again, in our demo, we were presenting a project that builds with CMake. Actually, this open source project also builds with Bazel, but for demo, we were presenting build configuration that is based on CMake. And to integrate into CMake, I used a dedicated CMake extension that was injected into build script. For Bazel, we also provide integration package, and there are some differences, but in general, the approach is the same. With the integration package, you just inject C++ Test CT to the build process, and then you have no additional setups or configurations. Code coverage is added to your build targets.
Okay. All right. Thank you, Mirek. We've also now passed our time limit. Thank you, everybody, for attending, for watching. I recommend please visit our website for the data sheet on C++ Test CT, more content, and we have other products and solutions also available for your verification challenges in your software development. So thank you again. Thank you, Mirek, very much. That was excellent. And any questions that you have after, please email us at info@parasoft.com, or we will go ahead and answer those via email for anything that was not addressed. All right. Thank you, folks. Say bye-bye, Mirek.
Bye.
Bye, folks.